All right, this is section 10.7 on polar coordinates. So in the rectangular coordinate system, x and y represent the directed distances from the coordinate axes to the point x, y. So x, obviously, if it's positive, we move to the right from the origin. If it's negative, we move to the left. Y, if it's positive, we move up from the origin, and negative, we move down. In the polar coordinate system, we actually have a fixed point, O, which is still the pole or the origin. We call it the pole sometimes in the polar coordinate system, though. Then we construct from O an initial ray called the polar axis. Generally, this is similar to having our x-axis. Then each point P in the plane can be assigned polar coordinates r, theta. R is the directed distance from O to P. So that's saying if it's positive, we go forward. If it's negative, we go backward. Theta is the directed angle. It's usually counterclockwise from the polar axis to the segment OP. If it was a negative angle, we would go clockwise. So our points are now going to be described using a radius and a theta, an angle. So here's how we plot these points in the coordinate system. My first point is 2 pi over 3. My radius is 2, which means I'm along this circle that is 2 units from the origin. And then my angle is pi over 3, so I go up to pi over 3, find where those two things intersect, and that is my point A. For point B, I have 3, negative pi over 6. Well, negative pi over 6 is down pi over 6, but my radius is 3 this time, so I'm on this outer circle. I go down pi over 6, and that's my point B. And for 3, 11 pi over 6. My radius is 3, so I'm out here on this 3 circle. Go all the way around to 11 pi over 6. And look at that. Point C is the exact same point as point B. So now you're going to try a few. All right, let's see how you did. 3, pi over 4. 1, 2, 3 is my radius. Pi over 4 is my angle. There's my point A. Realize that this is a different labeling of the polar axis. This one goes by pi over 12, so we have some extras that we don't usually use. 2, negative pi over 3. So radius is 2. Negative pi over 3 is right here. There's my point B. And my point C is at 2, so 1, 2, 5 pi over 3. Oh, look at that. B and C are the same point. So as we just saw, we can have multiple points with different coordinates that lay on the same spot. In rectangular coordinates, each point has a unique representation. No two different coordinates lie on the same spot. But this is not true for polar coordinates. For example, the coordinates r, theta and r, theta plus 2 pi are the same point. So I can just add 2 pi to my angle. If the radius is the same, it's going to be the same point. Also, r theta is the same as negative r, theta plus pi. So, to think about that in relation to our last problem, if I took negative pi over 3 and I added 2 pi, I got 5 pi over 3. That's why those were the same point. If I instead made this a negative 2, so let's see, 2, 5 pi over 3, that is going to be the same as negative 2, and then I can add or subtract 1 pi, which means it could be 2 pi over 3. That's the same exact point, because I would say, all right, well, my radius is negative 2, but I just like to say 2, and then I said, 2 pi over 3, but instead of going 2 forward, I actually go 2 backwards, and look at that, I'm on the same points. So now let's talk about how to relate rectangular and polar coordinates. In rectangular coordinates, we have a point x, y. X is how far left and right, y is how far up and down. In polar coordinates, we have a radius and an angle. Our point is radius, angle. To connect those, we look at this right triangle. X, y is the same as r, theta. They're the same point. So to convert from polar to rectangular coordinates, we know that cosine of theta is adjacent over hypotenuse. In this triangle, it's x over r. And sine is opposite over hypotenuse, which is y over r. That leads to two identities, and these are important. x is equal to r times the cosine of theta. Because if I solve this equation for x, I multiply the r over, I have r times cosine of theta. And y equals r times the sine of theta for the same reason. Whenever you are converting coordinates from one system to another, it's a very good idea to always sketch out the point first and check that your answer actually makes sense. Because sometimes you might have done something a little wrong, and sometimes there's some positive, negative situations involved. So let's convert to rectangular coordinates. To get my x value, I take my radius, which is square root of 3, times the cosine of my angle, which is pi over 6. Well, that means I have square root of 3 times the cosine of pi over 6 is square root 3 over 2, which makes my coordinate 3 over 2. To get my y coordinate, I take my radius, which is square root of 3, times the sine of my angle, pi over 6, which means I have square root 3 times 1/2, which is square root 3 over 2. So that means my coordinate is 3 over 2, comma, square root 3 over 2. Now thinking about that, square root 3 over 2, square root 3 over 2, okay, it should be up in the first quadrant. Well, a positive radius and pi over 6 is in the first quadrant, so we're good. All right, 2 comma pi. Well, to get my x coordinate, I take my radius times the cosine of my angle. The cosine of pi is -1, so I get -2. For my y coordinate, I take my radius times the sine of my angle. And the sine of pi is 0, so I get 0. I get the coordinate -2, 0. Well, if I think about that, an angle of pi is all the way over here. A radius of +2 goes out there. Hey, look, the point -2, 0 makes sense. And then we might also have to convert the other way around. To convert between rectangular and polar coordinates, we use the Pythagorean theorem to figure out r. X squared plus y squared equals r squared, because it's a right triangle. That must be true. And using trigonometry, we know that the tangent of theta is equal to opposite over adjacent, or y over x, which is how we find the value of theta. Remember that we then have to say, oh, okay, theta is the inverse tangent of y over x. Whenever we convert coordinates from one system to each other, sketch it out. This is where it gets really important. Because when I solve for r, I actually get a positive or a negative value. And I have to decide which one's right. When I solve inverse tangent, technically inverse tangent only gives me one angle, but if I'm saying the tangent of theta, it could be in 2 different quadrants. There's 2 different answers I kind of get out of that, so I have to decide which one makes sense. Also remember though, there are infinitely many correct answers for polar coordinates. So we're going to convert to polar coordinates. First thing I like to do is find r. So I take my x value squared plus my y value squared equals r squared. So I get 1 plus 1 equals r squared. R squared is 2. R is either positive or negative square root of 2. And I don't know which one yet, but I'll think about it in a second. Then I say the tangent of theta is y over x, so 1 over -1, which is -1. Tangent of theta is -1 when my angle is 3 pi over 4 or 7 pi over 4. I only think about the ones that are on the unit circle to simplify my life a little. Now I think about my picture. The point -1, +1 is right there in the second quadrant. Well, what angle is in the second quadrant? 3 pi over 4. Which of these 2 angles is in the second quadrant, actually? And if I take the angle that actually falls in that quadrant, I'm going to use a positive r value. I generally tend to only use the positive r value because it simplifies my life a little. So we have square root of 2, comma, 3 pi over 4. All right, for the next one, 0, 2, we find our radius, which is 0 squared plus 2 squared equals r squared. So I get 0 plus 4 is r squared. R squared is 4, which means r is positive or -2. Then I say the tangent of theta is equal to y over x. Well, wait, 2 over 0 doesn't exist, so where does tangent not exist? Tangent doesn't exist at pi over 2 and 3 pi over 2. Now I think about my point, 0, 2. That's right there on the y-axis. Well, what angle is the y-axis starting from the origin? That's pi over 2, and I always use the positive radius, so 2 comma pi over 2. If I had chosen 3 pi over 2 as my angle, I would just have to make that radius negative to go backwards. So these two represent the same exact point using those rules we talked about a little bit ago. And finally, we're going to talk about how complex numbers work. So previously, we've written complex numbers using the form a plus bi, where a and b were constants. A complex number can be understood as a point in the complex plane and can be determined by its corresponding rectangular or polar coordinates. When the complex number has rectangular coordinates, we write it as a plus bi. A is the real axis, b, the y-axis, is the imaginary axis. So the complex number 3 plus 2i can be represented as the point 3, 2. But we can do the same exact thing in the polar coordinates. A complex number has polar coordinates r theta if it can be expressed as r cosine theta plus I times r sine theta. R cosine theta, r sine theta, that's just like our conversion rules between rectangular and polar coordinates. So we have a complex number that's represented by a point in the coordinate plane. The complex number has the rectangular coordinates -2, -2. We're going to find one way to express the complex number using its polar coordinates. So to get r, just like always before, we take r squared equals x squared plus y squared. So r squared equals 4 plus 4. R squared equals 8, which means r equals positive or negative square root of 8. But we're going to want to simplify that. So r is positive or negative 2 square root 2. Then we also know that the tangent of our angle is -2 over -2, which is 1. So that means theta must either be pi over 4 or 5 pi over 4. Now we choose based on our coordinates. -2, -2 is down here in the third quadrant. I would go with the angle that's in the third quadrant and keep my radius positive. So my point is 2 square root 2, 5 pi over 4. But my complex number went from being -2 minus 2i to 2 square root 2 cosine of 5 pi over 4 plus 2 square root 2 sine of 5 pi over 4 I. So you can see complex numbers written that way as well. And your assignment will be a worksheet.